Good evening all. In this video, I will be teaching you about the basic solving techniques of network analysis. We all know that network analysis is the heart of electrical engineering, and the first part of the basic solving techniques in NA is Kirchoff laws. Who is Kirchoff? Kirchoff was a scientist who had huge contributions in networks for problem solving. So coming back to his laws now, Kirchoff law is of two types. The first law being the KCL or Kirchoff Current Law, and the second law being KVL called Kirchoff Voltage Law. Please don't confuse it with junction law or nodal laws and nodal loop laws, loop theorems. Don't confuse it. Now, however it is, I am going to teach all of you one by one everything. And please see that from the basics, we deal each thing separately, and then when I give you a problem, you can have any approach towards it. Like suppose right now I am giving you one problem, okay? It's all about problems here. Whatever we are doing, it's all about numericals, okay? Suppose I am giving you one numerical. You are a different person, I am a different person, he is a different person. So we might have certain own perspective or own kind of approach towards it. But when I am teaching you, kindly go serially. Suppose when I am teaching you KCL, try to apply KCL initially for any given problem. ऐसा मत सोचो कि मैं KCL कराने जा रही हूँ, एक प्रॉब्लम दिया आप उसमें KVL लगा दोगे, अरे कितना इजी था ये KVL लगा के. पहले KCL लगा के सीखो. Try to learn the KVL or KCL appropriately in the order what I am teaching you. Once you have a hand on it, you can give any approach towards it. I won't stop you. So now I will start with KCL. Once I teach you about KCL, we would solve some numericals on it. And the same would be done for KVL, later for nodal, then loop, etc. etc. So each of them will be done separately. KCL, KVL, mesh analysis and nodal analysis. So KCL, Kirchoff Current Law. I know most of you are familiar with its definition, but still silly mistakes do happen at times. Generally, KCL in many of the books are given as number of incoming currents to a node is equal to number of outgoing currents from that particular node itself. बहुत सारे books में दिया हुआ है. Take many books. It's given in a general form as number of incoming currents to one node is equal to number of outgoing currents from that same node. According to me, I am not saying that this is wrong. But, however, I think it's an incomplete statement. If I talk about KCL, the statement can be given as follows. Kindly please make a note. In any lumped network, the algebraic sum of currents at any node at any time t is equal to 0. Kindly please make a note. In any lumped network, the algebraic sum of currents at any node at any time t is equal to 0. 2 or 3 things from this we have to remember. The first is lumped network. Why do we mention lumped network here? Because KCL or Kirchoff Current Law is only valid for lumped networks and not for distributed networks. Kindly please make a note of it. Many a times in competitive exams, not like GATE, they won't ask you any theory questions as such, but like ESC or engineering service exams, they do ask you like what is KCL valid for distributed networks, which will be no, it is valid only for lumped networks. Also, KCL is not valid for high frequencies. It is valid only up to 1 megahertz. Kindly please make a note, 1 megahertz. Then, the algebraic sum of currents in any lumped network, the algebraic sum of currents at any node, at one node, suppose I take a node A, at that particular node, the algebraic sum of all the currents at any instant of time t is equal to 0. Suppose now we take this diagram where we have 4 currents I1, I2, I3 and I4 linked to this node A. I1 and I2 being the incoming currents, I3 and I4 being the outgoing currents. Incoming. I1 and I2 being the incoming currents and I3 and I4 being the outgoing currents. For us to apply KCL, first we need notations. And for our notations, we can take it you can take any notation for outgoing currents and incoming currents, but it should be same. Suppose you take negative for incoming currents, then for outgoing you have to take it positive while writing the equation. The opposite of incoming you have to write for outgoing. Now for our convenience, from now on, I will always take incoming currents as positive and outgoing currents as negative. So I1 and I2 here are incoming currents. I take them as positive. ले लो positive, I1 को positive लो, I2 को positive लो. I3 and I4 being outgoing currents, I take them as negative. It is my notation what I am giving you. I take them as negative. क्यों? क्योंकि I1, I2 को मैंने positive ले लिया. So I3 and I4 I take it as negative. So according to KCL, I can write I1 plus I2 minus I3 minus I4 is equal to 0. Why? Algebraic sum of all currents at any node. Here हमारा node है A, तो हमने KCL लगाया किसमें? A में. हमारा incoming current है I1, I2. दोनों को positive डाला according to our configuration, whatever we have taken the notations. I3, I4 को हमने negative लिया. क्यों? Outgoing currents equals to 0. I3, I4 को इस side लेके जाओ. Now I1, I2, that is I1 plus I2 is equal to I3 plus I4. इसको हम क्या लिख सकते हैं? Summation of incoming current is equal to summation of outgoing currents. यही है आप लोगों का स्टेटमेंट जो बहुत सारे बुक्स में दिया हुआ रहता है. Summation of incoming current is equal to summation of outgoing current. आता कहाँ से है? ऐसे आता है. Now, again when we go towards I1 plus I2 is equal to I3 plus I4, I1 को क्या लिख सकते हैं? Q1 by T. Why? Because the rate of change of current is called my bad. Rate of flow of charge. So Q by T is equal to what? Current. So I1 can be written as Q1 by T. I2 can be written as Q2 by T. I3 can be written as Q3 by T. And I4 can be written as Q4 by T. So I1 plus I2 is equal to I3 plus I4 can be written as Q1 by T plus Q2 by T is equal to Q3 by T plus Q4 by T. Here, if we take T as common, it comes as Q1 plus Q2 is equal to Q3 plus Q4. Now, what is this? Now, this is conservation of charge. This is called conservation of charge. Got it? So, we can say that KCL follows conservation of charge. This is the theory part, whatever is needed for KCL. Kindly please go through it. Now, we'll solve some numericals for you to understand in a better way. The first problem we have here is this one. In this circuit, we are supposed to find 3 currents I1, I2, I3. कभी भी कोई भी सर्किट दिया हुआ हो, कोई भी प्रॉब्लम दिया हुआ हो, first look at the data, the complete data, whatever is given to you and whatever you need to find out. There are some of the techniques I want to share. Kindly please make a note of it. For making notes, write questions with a black pen and answers with a different color pen or whatever. Use different color pens whenever you are doing network analysis, or else you will get confused while following your own notes. And it will be easy for understanding too. Second point what I would like to say, first look at the question and think. What is your approach? I always told, since the beginning of this video I am telling you, everyone's approach is different. So first look at the question. Think what can be your approach, how to start looking at the data. What is the easiest way? क्योंकि जो problems मैं कराने जा रही हूँ उसमें अभी KVL भी लग सकता है, लेकिन what is the easiest way? आपको मैं वो चीज समझाऊंगी जब हम सारे टेक्निक्स सीख जाएंगे, लॉज सीख जाएंगे, and we'll start solving a circuit with anything. Like एक प्रॉब्लम दिया जाएगा उसमें आपको कुछ भी लगाना पड़ेगा, कोई मतलब पर्टिकुलर KCL, KVL, नोडल, मेश ऐसा नहीं होगा. You should apply, you have the chance of applying any approach. At that particular time you will understand कि कौन सा लगाना है, कैसे स्टार्ट करना है. That is the main thing. So first look at the question and think. Think, because it is not about concept, it is also about time. Third, choose the shortest path. जो आपको लग रहा है सबसे shortest path है वो आपको प्रैक्टिस करते करते हाथ में आएगा, not now. So first we'll take this particular example. Here we are supposed to find three currents, I1, I2, I3. Okay, many of you might think of applying KVL here because that's how we have been taught. कोई भी हम सर्किट देखते हैं हम सोचते हैं अरे यार उसमें लगा दो KVL, लगा दो, इक्वेशन लिखो, सॉल्व करो, आंसर आ जाएगा. However, let's see the KCL approach towards it. You see how quickly the answer comes, and then you understand the importance of this KCL or Kirchoff Current Law. Because ज्यादातर क्या होता है, हम KCL का बस थियरी पढ़ के जाते हैं, we don't have any approach towards it. हम सोचते हैं क्या ही होगा, number of incoming currents, summation of all incoming currents equal to summation of all outgoing currents to one particular circuit. लेकिन whenever you think that ठीक है यार KCL को हम अगर नहीं भी पढ़ के चलेंगे तो भी ठीक होगा, हम कोई भी प्रॉब्लम इजीली KVL के साथ सॉल्व कर सकते हैं, पर एक बार KCL का अप्रोच लगा के देखो एट वेरी बिगिनिंग ऑफ सच प्रॉब्लम्स व्हेन यू हैव नोट्स गिवन टू यू ऑलरेडी. ओके, सी सपोज दिस इज द प्रॉब्लम व्हाट इज गिवन टू अस. यू कैन क्लियरली सी थ्री नोड्स A, B, C और मेनी अदर टू, बट हम इजी वे में कर रहे हैं तो A, B, C तीन नोड्स ले रहे हैं. ओके, so first we'll give KCL at A. We'll take KCL at A. 8 minus I1 minus 12 is equal to 0. Why? Because 8 is incoming towards A, I1 and 12 is outgoing from A. So I1 from here comes as minus 4 ampere. KCL at B, 9 minus 8 minus I2 is equal to 0. From that I2 comes as 1 ampere. Please आप लोग KCL at C लगाइए. I3 will easily come as minus 3 ampere. Don't change the signs when you are trying to do KCL at C. I1 हमारा minus 4 आया है और हमको पता है कि अगर इनकमिंग करंट आ रहा है हम लोग पॉजिटिव लेंगे. इसका मतलब ये नहीं कि हम minus 4 को 4 लेके चले. We will take the sign as it is. Don't change the sign. अगर हम लोग का अभी I1 ऊपर की तरफ होता मतलब opposite sign होता outgoing from that node C, then we would have taken minus of minus 4. Understanding? जो जैसा दिया हुआ है वो वैसा ही लीजिए अभी यहाँ पे. And hence we get I3 as minus 3 ampere. देखिए within 10 seconds, 10 to 15 seconds you have the answer in hand. Whereas अगर आप इसमें KVL लगाते you would have got confused with the resistance values and the current values and it becomes very huge. Second problem, when you see here we have again a circuit given to us and we got to find three currents I1, I2, I3. इसमें भी KVL approach लगा सकते थे. KCL लगा के देखो, तीन नोड लो A, B, C, करंट्स दिया हुआ है. KCL at A लगाओ. 1 plus I1 minus 10 minus 2 is equal to 0. Now by now you understand what is incoming, outgoing and what are the notations we are trying to use here. With this equation we get I1 as 11 ampere. KCL at B लगाओ. 3 plus 2 minus I2 minus 1 is equal to 0. I2 is equal to 4 ampere. KCL at C लगाओ. Minus I3 minus 3 plus 4 is equal to 0. I3 is equal to 1 ampere. See how easily this circuit is solved with KCL. Similarly, we'll do some other numericals. There are lots and lots of numerical. One full class I'll be taking for you for KCL numericals only. Then we'll go to KVL, we'll do all KVL numericals. Then we'll go towards mesh analysis, nodal analysis, and at the end of the day, जब सारा टेक्निक्स हम सीख जाएंगे, जब सारा लॉज हम सीख जाएंगे, हम एक साथ विल बी ट्राइंग टू सॉल्व ऑल गेट प्रॉब्लम्स ऑफ द लास्ट 15 years and we'll try to see what are the best approaches we can make. I hope you have liked the video and I hope you have understood it quite well. Your concept has been clear. Kindly wait until my next